This question is perfect square, so you are given the integer n, so you have to return the base number of perfect square let's sum out to the n. So the perfect square represents what? 1, 4, 9, 16, and then so on, right? So imagine there's an index that is not perfect square, then definitely the value is not going to be what? So you probably won't have to update value for the non-perfect square index, right? So when n equal to 0, right? If n equal to 0, there's only 0 way, right? If n equal to 1, 1 is a perfect square of itself, so it is 1. How about 2? 2 is actually equal to 1 plus 1, right? 1 is a perfect square, 1 is plus 1 is a perfect square, right? So it will be 2. And then 3 is going to be 1 plus 1 plus 1, right? This is 3. And then 4 is actually equal to what? Perfect square is actually equal to 4 right over here, right? So it's going to be 2 to the 2, right? So this is actually equal to 1. And then 5 is actually equal to what? 1 plus 2 to the 2, right? So this is actually equal to 2. And then you can keep doing this. So if you notice, like, we are actually grabbing the perfect square element dp variable, right, to update our the future index if they are the perfect square index, right? So we will definitely have to traverse what? Traverse the n from what? From 1 to what? To n, right? And then when we want to calculate the perfect square, right? We basically need to what? Traverse another. This is I, and then this is j, and then we have to traverse the perfect square for j in I. So imagine I minus j square, right? If this is greater or equal to 0, right? Imagine 4. 4 minus 2 to the 2, right? If this is greater or equal to 0, then we can grab the element in the dp, and then we plus 1, right? So this is pretty much the idea, right? So let's start coding. So we have what? We have in array dp and new int n plus 1. The reason why I use n plus 1 is because the base index is starting from 0, and then I can traverse. So I equal to 1, I less than equal to what? Then I plus plus, right? And then I will just initialize my dp current index to the I. So this is a big number, right? So dp 100 is going to be equal to 100, right? But I would keep updating based on my I minus j square, right? So j equal to 1, and then j equal to 1 and I minus j square, right? This is square equal to 0, and then j plus plus. So this is a square of j, and then I is the number I'm traversing. So if this is valid, right, I can grab the element to update the dpi method mean dpi comma is either dpi or dp I minus j times j, right, and then plus 1, right? So think about I equal to 4, right, and then j equal to 2. 2 times 2 equal to 4, right? So 4 minus 4 is actually equal to 0, right? So imagine this is 4 and this is 2. 2 times 2, right? So you will get what? You will get dp 0. dp 0. dp 0 is actually what? We didn't touch anything in dp 0, right? dp 0 is by default is 0. Then we plus 1, which is going to be 1. And then this was initially what? When I equal to 4, then dp4 equal to 4, right? Then I know this is a minimum, so I will grab the 4 comma 1. So which one is the minimum? dp4, right? This is going to be 1. So I update my dp4 equal to 1 right over here. So at the end, I will just have to return dpn, right? And this is pretty much it, right? So let me submit. So let's talk about the time and space. For the time, this is all of n, and this is actually n squared. Square root of n, right? So it's all of n, times square root of n. So this is the time. So n square root of n, this is the time, and then the space, this is all of n, right? So this is a time and space complexity. So if you have any question, I leave a comment and I'll see you next time. Bye.